Okay, so as we're talking about creating mathematical laws or rules to describe the relationship between position, velocity, and acceleration in time, we need to start to get used to how we can manipulate these formulas to meet our needs. And we're going to end up with 5 different formulas, and don't worry, you'll never have to memorize them, although I'm sure some of you will. You'll always get these on tests. My only concern is that you know how to use these formulas and how to be able to decide on which formula that you need to use. But anyway, we designed several formulas for certain circumstances. My favorite one is where we don't have time. We're not given time, and we have to use the final velocity with constant acceleration formula without time to solve problems. So we create these formulas with different goals in mind. Do we want the final position or the displacement if in the circumstance where we don't have a final velocity, or where we have both the initial and final velocity but no acceleration? So we create these different circumstances, and we're going to start with we're going to use the average velocity formula to create a formula to determine displacement under the conditions of constant velocity. Okay, so that's our first goal here. Use the average velocity formula to create a formula to determine displacement or final position under the conditions of constant velocity. So we know what our average velocity formula is. It's V, except we need a bigger line there. V equals delta x over time. And we know that we can expand delta x because it's the change in time, or the change in position, right? So it's the final position minus the initial position over time. And this is a formula we want to use, and we want to create a formula that solves for how far did I go? Okay, my final position minus my initial position. How far did I go given a certain velocity and a certain time? So all we're going to need to do here first, if I want to get x by itself, we're going to have to move the denominator over here. So we're going to multiply both sides of the equation by time, and that's going to end up giving us time times velocity equals x minus x0. Okay, so I just multiplied both sides of the equation times time, and here I can do this. Time cancels out over here and leaves me with that. Okay, the next thing I need to do if I want to get x by itself is I need to add x0 to both sides of the equation. So I'm going to add x0 and add x0. Okay, and that leaves us with x equals x0 plus velocity times time. Okay, that's going to be our first equation, and this is what I want you to put on your worksheet. This derivation. This is called a derivation. We derived the formula. We started with the velocity formula, and we ended up with this formula. And we want to name this so that it gives us a clue as to what it's used for. Okay, so we're going to call this the final position, because that's what we get, right? That's what we end up with, the final position. Final position. And this is under the circumstances of constant velocity. This v here cannot be an accelerated velocity. It has to be a constant velocity, or this formula doesn't work. So we're going to say final position with constant velocity. And that's what you need to put down for the name this part of it on your worksheet. Final position with constant velocity. Okay? So this is the first equation that we've gotten. So we're on our way. We're gonna kill it here. Okay? So go ahead and go to the next one.